Hello everyone, today we will be presenting our research project Guida, Multimodal Virtual Experience for Design Schools in the Immersive Web, as part of the Digital Representation and Digital Heritage session. My name is George and I will be presenting today together with Runjia and Yuebin from the Harvard Graduate School of Design. The research aims to respond directly to the effects of the COVID-19 pandemic when most schools, universities, and gathering spaces became fully virtual. Universities, such as the test site for this research project, the Harvard Graduate School of Design, went from spaces that provided educational, social, and psychological needs of students through the various in-person activities to completely virtual modalities, dictated by static interfaces and limited communication platforms. This project creates a space that seeks to address this issue, first through the digitization of familiar spaces, physical spaces, and then through their augmentation via WebXR technologies. The gamification strategy is adopted where users can virtually learn, collaborate, and socialize through personalized avatars within a dynamic and multisensorial digital environment. The project builds upon the wide experiential potential of digital platforms otherwise not possible in reality, and implements a customized multimodal user interface.
Our projects are related to many aspects of telepresence and video telecommunication technologies, such as video conferencing. Video conferencing are used for organizing virtual conferences via video communication. As early as 1998, Ishimura proposed the use of a gamification strategy in video conferencing system called Framework. In 2015, Corella now proposed a VR tool that allows communication between various stakeholders in virtual space during the architecture design process, which also brings the discussion of user embodiment in collaborative with virtual spaces. Clark and Maher investigate the roles of place in virtual design studios, where students learn and communicate virtually in an immersive 3D virtual world that brings design education in virtual spaces into discussion. In this project, we leverage the latest WebXR technology, a web-based immersive virtual communications, such as Mozilla Hubs and Facebook Horizon Beta are two of the precedents of such case. We built an asymmetrical system that offers rich modalities of interaction that accommodates various platforms. The entire project was created on Glitch platform for collaborative coding. We also developed a front-end system with the open-source JavaScript package Vue, AFrame, and Three. The project makes use of WebRTC, a peer-to-peer framework for real-time audio communications between users. We deploy our Node.js backend server to handle user data and file management. Next page. We build a responsive virtual environment enhanced by multimodal user interactions, including audio system, the visual system, and motion system. This is some of the code of our front-end with AFrame and Three.js. And here are some examples of our backend using Node.js.
Guida.io's digital replication of Gundhall augments the academic university environment through this new multi-user web experience. Therefore, the common uses of these spaces and physical working areas are transformed into interchangeable virtual environments through new exhibition spaces, physical lecture halls, dynamic installation rooms, waiting spaces for meeting rooms, and customizable areas to meet, collaborate, and have reviews. The user interface is envisioned as a seamless display with 3 accessible and intuitive navigation settings, as seen below. Through the augmentation of reality, multimodal virtual environments enable deeper and richer virtual experiences. Following a period of user testing, we developed 3 main types of interaction modalities: vision, audio, and motion system. Vision functions as a principal form of interaction within this 3D main room. Visual experiences begin with the virtual reconstruction of the centralized architecture school as a prototype for educational virtual spaces. Virtual avatars are used to metaphorically represent the human body. Through the removal of physics engines, users are able to point with their mouse and interactively fly across each space and use locomotion checkpoints to accelerate motion. The gamification strategy allows the combination of 2D and 3D objects, and our audio system instead simulates the physical experience based on proximity.
Finally, we created a file management interface that allows users to upload and store personal content, including images and 3D models. It has a 3D preview mode which has an orbit camera. Users can resize and move files to arrange them, and the interface can copy the content to the corresponding space. This prototype provides a virtual platform for students to learn and collaborate during their school or online only. During the pandemic, when so many institutions are running virtually, this platform can be a centralized hub for social activities. The immersive multi-sensorial environment of this platform can meet users' psychological needs. Now, the personalized content interface requires the precise spatial coordinates from users. We are working on making this function smoother. The current version of this platform serves for the design school in our university. We expect it to serve wider communities, for example, the whole universities. Finally, as we gradually move into a transition period of hybrid or in-person learning model, a feedback loop between the virtual and physical can be built to extend the physical space. And here are our references, and thank you for listening today.